Hydrochloric acid can help detect carbonates. Add dilute hydrochloric acid to a solution containing carbonate ions if physics. As carbonate ions react with H plus ions forming CO2. CO2 minus solid plus 2H plus aqueous RO CO2 gases plus H2O liquid. Test for carbon dioxide with lime water. Bubble gas through test tube of lime water. If lime water goes cloudy, solution containing carbonate ions. Testing for halides with silver nitrate solution. Add dilute silver nitrate. Add dilute HNO3 nitric acid. Add silver nitrate solution. Chloride gives a white precipitate silver chloride. Bromide gives a green precipitate silver bromide. Iodide gives a yellow precipitate silver iodide. If you think a solution contains OH minus ions using a pH indicator, test for hydroxide ions. Hydroxide ions make solution alkaline. Dip a piece of red litmus paper in the solution. If hydroxide ions present, the paper turns blue. Test for sulfates with HCl and barium chloride. Add a little dilute hydrochloric acid. Add barium chloride solution. If a white precipitate barium sulfate forms, it means the original compound contained sulfate. Hydrochloric acid, why do we add it? It's to remove traces of carbonate ions before you do the test, as these also produce a precipitate, therefore confusing the results. Using red litmus paper and sodium hydroxide test for ammonium ions. NH3 is alkaline, therefore we test using damp piece of red litmus paper. It needs to be damp so ammonia gas can dissolve. If you add OH minus ions to a solution containing H4 plus ions, they will react to form NH3 gas in water. If ammonia is present in the damp piece of red litmus paper, the paper turns blue. NH4 plus aqueous plus OH minus aqueous to form NH3 gases plus H2O liquid. Testing for a substance containing H4 plus ions. Add dilute sodium hydroxide solution to mystery substance in test tube. Gently heat the mixture. If ammonia is given off, the mixture contained ammonium ions must be present. If ammonia is given off, ammonium ions must be present. If ammonia is given off, ammonium ions must be present. Using flame tests to identify group 2 ions, dip a nichrome Y loop in concentrated hydrochloric acid. Dip the Y loop into a known compound. Hold the loop in clear blue part once burn a flame. Observe the color change in the flame. Dip a nichrome Y loop in concentrated hydrochloric acid. Dip a nichrome Y loop in concentrated hydrochloric acid. Dip the Y loop into a known compound. Hold loop in clear blue part once burn the flame. Observe color change flame. Ca2 plus ion, brick red flame color. Sr2 plus ion, red flame color. Ba2 plus ion, pale green color flame color. Using dilute sodium hydroxide solution to identify group 2 ions, add sodium hydroxide dropwise to a test tube containing the metal ion solution and observe the precipitate that forms. Sodium hydroxide, keep adding sodium hydroxide until excess, record any changes that you see. Mg2 plus ion with OH minus, slight white precipitate with excess OH minus ions, white precipitate. Ca2 plus OH minus ions, slight white precipitate with excess OH minus ions, slight white precipitate. SR2 plus ions with SR2 plus with OH minus, slight white precipitate with excess OH minus and slight white precipitate. Ba2 plus ions with OH minus, no change, with excess OH minus, no change. Silver nitrate solutions used to test for halides. Add dilute HNO3 to remove ions. Why do you add dilute nitric acid to remove ions which might interfere with the solution? Add few drops of silver nitrate solution aqueous. A precipitate is formed as silver halide. F minus, no precipitate. Cl minus, white precipitate. Br minus, green precipitate. I minus, yellow precipitate. That's easy. But another thing is that the idea that Cl minus forms the slowest, I minus forms the fastest. And it's very specific on mark schemes. Sometimes I think it was like stated observation, and if you said a white precipitate, you won't get the mark. It was you need to say white precipitate forms slowly or slowest. Yeah, they're very, very specific. Each silver halide has a different solubility in ammonia, therefore we can test these by adding ammonia. Cl minus white precipitate dissolves in dilute NH3 aqueous. Br minus cream precipitate dissolves in concentrated NH3 aqueous. I minus yellow precipitate insoluble in concentrated NH3 aqueous. Most soluble, least soluble. So Cl minus white precipitate dissolves in dilute NH3 aqueous. Br minus cream precipitate dissolves in concentrated NH3 aqueous. I minus yellow precipitate insoluble in concentrated NH3 aqueous. Most soluble, least soluble. NaI solid plus H2SO4 liquid form NaHSO4 solid plus HI gases. 2HI gases plus H2SO4 liquid form I2 solid plus SO2 gases plus 2HO liquid. 6HI gases plus SO2 gases to form 3I2 solid plus H2S gaseous plus 2H2O liquid. HI reduces H2S4, then HI reduces SO2 to H2S. NaBr solid plus H2S4 liquid form NaHSO4 solid plus HBr gaseous. This diffuses the HBr gas, which is strong reducing than HCl and reacts with H2S4. Then 2 HBr gases plus H2SO4 liquid form Br2 solid plus SO2 gases plus 2H4 liquid. Reaction produces choking fumes of SO2 and orange fumes of Br2. NaF solid plus H2SO4 liquid with NaHSO4 solid plus HF gaseous. NaCl solid plus H2SO4 liquid with NaHSO4 solid plus HCl gaseous. Mr. fumes as gas comes into contact with moisture in the air. HF and HCl are not strong enough reducing agents, therefore reaction stops. There's no redox reaction. Reducing power of halides increases down the group. To reduce something, the halide ion needs to lose an electron from its outer shell. Halide ion needs to lose an electron from its outer shell. How easily this happens depends on the attraction between nucleus and outer electrons. Greater reducing power, greater the reactivity, faster reduction reactions. Greater reducing power, greater reactivity, faster reduction reactions. Burning fossil fuels to produce electricity produces sulfur dioxide, which produces atmosphere. Flue gases emitted from industrial exhaust chimneys. Wet scrubbing. Acidic sulfur dioxide can be removed from flue gases by reacting with alkali. Powdered calcium oxide or calcium carbonate can be used. Slurry made by mixing calcium oxide or calcium carbonate with water. Then it's sprayed onto flue gases as the sulfur dioxide reacts with alkaline slurry, producing calcium sulfite, a solid waste product. CaO solid plus 2H4 liquid plus SO2 gases from CaSO3 solid plus 2H4 liquid. CaCl3 solid plus 2H4 liquid plus SO2 gases from CaSO3 solid plus 2H4 liquid plus CO2 gases. TiO2 is converted to TiCl4 by heating it with carbon in a stream of chlorine gas. Then TiCl4 is purified by fractional distillation, then reduced by magnesium in a furnace at 1000 degrees Celsius. Titanium is used in the bodies of modern planes. TiCl4 gases plus 2 mg liquid are at Ti solid plus 2 mg Cl2 liquid. That's why we formed titanium, because titanium is useful in the bodies of modern planes. X-rays pass through soft tissues, digestive system. Therefore, they don't show up. They won't pass. They don't show up on the X-rays, showing the stomach, for example, or internal organs. Whereas barium sulfate is opaque to X-rays. It won't pass through the X-rays. It's used in barium mules to diagnose problems with esophagus, stomach, intestines. Patient swallows barium meal, a suspension of barium sulfate, and the barium sulfate coats the tissues, showing up on X-rays, showing the structure of organs. Group 2 compounds used to neutralize acidity, also known as alkaline earth metals. Calcium hydroxide, slaked lime used in agriculture to neutralize acid soils. Magnesium hydroxide used in indigestion tablets as antacid, substance which neutralizes excess stomach acid. Magnesium hydroxide, very low solubility, sparingly soluble. Barium sulfate is insoluble. Group 2 hydroxide/sulfates are all white when solid. If acidified barium chloride solution is added to a solution containing sulfate ions, sulfate ions in the white precipitate of barium sulfate is formed. Compounds of group 2 elements containing OH- ions, singly charged negative ions, increase solubility down group. Compounds of group 2 elements containing doubly charged negative ions, SO42- ions, decrease solubility down the group. H plus aqueous plus OH- aqueous to form H4 liquid, ionic equation for neutralizations. Group 2 hydroxide/sulfates all white when solid. Here you go. Magnesium, calcium, SrBa, OH- SO42-, least soluble, most soluble. Increase in solubility down the group. Most soluble, least soluble. Decrease in solubility down the group. When group 2 elements react with water, they oxidize from 0 to +2, forming M2 plus ions. M solid plus 2H4 liquid form MgE. M solid plus 2H4 liquid form M bracket OH squared aqueous plus H2 gaseous. M solid plus 2H4 liquid ROM OH squared aqueous plus H2O gaseous. Water is an oxidizing agent. Group 2 elements lose 2 electrons when they react. They lose 2 outer electrons, form 2 plus ions, and they have electronic structure of a noble gas. BeMgCaSrBa doesn't react. Magnesium reacts very slowly with water. Calcium reacts steadily with water. Sr reacts very quickly with water. Ba reacts very rapidly with water. Reacts more readily down the group as ionization energy decreases. State 2 reasons attraction gets weaker down the group. Ions get bigger, so electrons further away from positive nucleus, extra electron shells, so greater shielding effect. Further down the group, halide ion is easier to lose electrons and therefore greater reducing power. Greater reducing power, greater reactivity, faster reduction reaction takes place. Greater reducing power, greater reactivity, faster reduction reaction takes place. In sunlight, chlorine can decompose water to form chloride ions and oxygen. Chloride ions kill bacteria. CO2 gas plus H2O liquid reversible reaction to H plus aqueous plus 2Cl minus aqueous plus Cl minus aqueous plus ClO minus aqueous. 0 plus minus 1 plus 1 oxidation stage. 2Cl2 gaseous plus 2H2O liquid reversible reaction for H plus aqueous plus 4Cl minus aqueous plus O2 gaseous. If we mix chlorine with cold dilute aqueous sodium hydroxide, we get NaClO aqueous, sodium chlorate, one solution. 2NaOH aqueous plus CO2 gases, RO NaClO aqueous plus NaCl aqueous plus H2O liquid. 0 plus 1 minus 1 oxidation stage. Sodium chlorate, one solution. Bleach uses bleach paper to bleach paper / textiles, good for cleaning toilets using water treatments. Chlorine kills disease-causing microorganisms. Chlorine persists in water and prevents infection further down the supply. Prevents the growth of algae. Algae, removing bad taste / smells, removes discoloration caused by organic compounds. However, it's harmful if breathed in, irritates the respiratory system, plus liquid chlorine causes severe chemical burns if it's on the skin. If liquid chlorine is on the skin / eyes, causes severe chemical burns. Water contains a variety of organic compounds for example, from decomposition of plants. When chlorine reacts with these compounds, form chlorinated hydrocarbons, which are carcinogenic, cancer. Say what happens when halogens react to gain an electron, they get less reactive down the group because atoms become larger, outer shell further away from nucleus, so electrons are less strongly attracted to it. Halogen will displace a halide from solution. Halide is below in the periodic table. F2, Cl2, Br2, I2. F2, pale yellow gas, Cl2, green gas, Br2, red-brown liquid, I2, grey solid. Group 7 electronegativity, it decreases down the group. As halogens are all highly electronegative elements, so you'd be like it increases, right? No, because larger atoms attract electrons less than smaller ones, as electrons are further away from nucleus and are shielded by more electrons. Halogens are all highly electronegative elements. Larger atoms attract electrons less than smaller ones. Electrons are further away from the nucleus and shielded by more electrons. And group 7 boiling point increases down the group because large atoms, more electron, size of atom increases, therefore stronger van der Waals forces. I don't really go for that part because that's not that difficult compared to this. Add Cl2 aqueous colorless, add Br2 aqueous orange, add I2 aqueous brown, KCl aqueous colorless, KBr aqueous colorless, Ki aqueous colorless. If you add Cl2 aqueous to KCl aqueous, we get no reaction. Add Cl2 aqueous to KBr aqueous, orange solution Br2 formed. Add Cl2 aqueous to Ki aqueous, brown solution I2 formed. Orange solution Br2 formed for the KBr. Add Br2 with KCl, no reaction. Add Br2 to KBr, no reaction. Add Br2 to Ki. Brown solution I2 formed. Add I2 to KCl, no reaction. Add I2 to KBr, no reaction. Add I2 to Ki, no reaction.